In this video, we will examine the procedures for recovering data from RAIDZ1, RAIDZ2, RAIDZ3, and ZFS Stripe arrays created in the TrueNAS SCALE operating system. We will demonstrate the sequence of actions in the event of a server hardware failure and the methodology for restoring access to a data pool when one or more drives fail or when information is accidentally deleted from the array. In addition to hardware malfunctions, we will consider data recovery after deleting an entire dataset, pool corruption, critical operating system crashes, ZFS file system damage, errors when adding new disks, incorrect controller operation, and accidental drive initialization in another system. The data recovery process takes place in the Linux Ubuntu operating system, but it is also possible in Windows and macOS environments. The Hetman RAID recovery program automatically detects connected disks and the array configuration, regardless of the platform, and allows for the safe recovery of files and folder structures in any of these systems. Using Hetman RAID recovery, you can successfully restore access to files even in cases of critical array failures or hardware damage to the server. The program allows for the safe recovery of data from damaged or deleted pools and datasets while preserving the file and folder structure. TrueNAS is an open-source operating system for building network-attached storage, NAS, based on Linux and utilizing the ZFS file system. It provides data protection, integrity checking, efficient disk management, and supports running virtual machines. The platform supports various RAID types, including RAIDZ, which combines performance and fault tolerance. TrueNAS Scale allows for horizontal scaling by combining multiple nodes into a cluster, while maintaining key ZFS functions, data self-healing, snapshots, compression, deduplication, and encryption. The system is compatible with SMB, NFS, ISCS, and S3 protocols, and also allows for running containers and Kubernetes, making it a versatile solution for data storage and processing in various environments. RAIDZ is a redundant array of disks in ZFS with distributed parity. The use of variable length blocks optimizes writing and allows for automatic error correction during reading. When recovering a degraded array, resilvering, the load on the other disks increases significantly. Therefore, RAIDZ is best suited for environments with moderate fault tolerance requirements or for small capacity disks where the array recovery time is minimal. In the event of a failure of hardware components of the server, such as the power supply, motherboard, or disk controller, direct access to data from the operating system becomes impossible. Such situations also arise when the server stops booting due to a critical error during a TrueNAS Scale update, or if the system partition is corrupted. Even if the files and disks are not physically damaged, access to the RAIDZ array may be lost, and standard ZFS tools may not allow you to see the drives or import the pool. In these cases, specialized software such as Hetman RAID recovery allows you to safely gain access to the data and recover the information. In this example, we will show the data recovery process in automatic mode on a computer running Ubuntu. First, turn off the server and carefully remove all the disks that were part of the array. Connect them to a workstation. The optimal option is a direct connection to the motherboard via SATA cables for maximum speed and data transfer stability. If the motherboard lacks free ports, you can use external USB docking stations or USB adapters for the disks. Keep in mind that when connecting via docking stations, the scanning speed may be lower, so for large volumes of data, it is preferable to use internal ports. After connecting, check that the disks are displayed in Ubuntu in the Disks application, but do not initialize them if the system prompts you to do so. Immediately after checking, proceed to launch Hetman RAID recovery to automatically assemble the array. A key feature of Hetman RAID recovery is its deep analysis of ZFS metadata. The program does not need a functional operating system or controller. It reads service information directly from the disks and automatically recreates the pool structure. Since ZFS stores all critical data about the array configuration within the pool itself, the logical integrity of the files is preserved even in the event of complete server environment unavailability. As a result, the user gains access to the data in a familiar form, without being dependent on the original system. In this video, various array configurations are used for demonstration. RAIDZ1 on 3 disks, RAIDZ2 on 4 disks, RAIDZ3 on 5 disks, and a Stripe array on 2 drives. We will examine the recovery algorithm for a RAIDZ1 array of 3 disks, specifically for a situation of complete hardware server failure or a critical error after a TrueNAS scale update. Importantly, this approach is universal and can also be applied to RAIDZ2, RAIDZ3, and Stripe configurations. After launching, Hetman RAID Recovery automatically performs a scan of all connected devices. The program reads the ZFS service metadata, analyzes the configuration of VDEV virtual groups, and restores the correct RAIDZ1 model based on the data obtained. The main window displays the detected drives and the assembled logical structures. You can immediately continue working with them, perform a detailed analysis, view the data structure, or recover the necessary files. Select the required RAIDZ1 from the list of reconstructed arrays and start the fast scan mode to quickly determine the data structure. Once the scan is complete, the recovered file system with its full hierarchy of directories and files will be displayed in the main window. Select the necessary objects and click Recovery. In the next step, specify the folder for saving the data, preferably on a separate storage medium with sufficient free space. Confirm the start of the process, specify the final save path, and click Recovery again to begin copying. After the operation is complete, click Finish. Ultimately, the data from the ZFS RAIDZ1 pool will be recovered and become available for further use in its usual form.
Now let's consider a case of failure of one or more disks in a RAIDZ array. RAIDZ architecture provides fault tolerance depending on the type of array. RAIDZ1 allows for the loss of 1 disk. RAIDZ2 allows for 2. RAIDZ3 allows for 3. In the case of a Stripe array, there is no redundancy, so the failure of any drive leads to total data loss. If it is not possible to connect all the disks, you can create an image of the missing drive and use it along with the other disks for further recovery. Thanks to distributed parity mechanisms and data integrity control, specialized software, specifically Hetman RAID Recovery, is capable of reconstructing lost blocks and restoring access to information, as long as the number of failed disks does not exceed the allowed level for the specific RAIDZ type. If this threshold is exceeded, the logical structure of the array is broken, and standard software methods become ineffective. In such situations, recovery is only possible using professional equipment in specialized laboratories. Ensure that the target medium has sufficient free space to save the recovered data. Carefully remove the disks from the server and connect them to the computer via SATA ports or an external docking station. It is important to avoid writing any new data to these drives, as this could lead to irreversible data loss. If the architecture of your workstation does not allow for connecting all disks simultaneously, the optimal solution is to use virtual disk images. This method involves creating exact bit-by-bit copies of each disk for further analysis. Detailed instructions for creating images are available in previous videos on our channel.
Let's break down the data recovery process using the example of a RAIDZ3 array in which 3 disks failed simultaneously. This array configuration allows for data recovery even in the event of such a serious failure. We will perform this using the Hetman RAID Recovery utility. Immediately after opening, the program independently checks all connected drives, reads the service information, and restores the original array structure based on it. Select the found RAIDZ3 and activate the fast scan mode. As soon as the check is finished, the full structure of the reconstructed array with all directories and files will be displayed in the working window. Select the required elements and click Recovery. Then, specify the folder for saving and confirm the operation by clicking Recovery again. When copying is complete, click Finish. After completing all stages, the recovered files from the RAIDZ3 array will be fully usable in standard mode. Finally, let's look at one of the most common situations: accidental deletion of files from a RAID array. In this example, we are recovering data from a Stripe array created from 2 disks
under the ZFS file system. The peculiarity of a Stripe array is that data is distributed across all disks without any redundancy. This means that no single disk contains complete files. For successful recovery, you need to connect all disks simultaneously and work with the array as a single logical structure. If one of the disks is missing or not connected, the program will not be able to read the data. Before starting, make sure all disks are physically connected to the computer, either directly via SATA to the motherboard or using an external docking station. It is critical not to write new data to these disks and not to initialize them in the system to avoid overwriting the lost files. In Ubuntu, launch Hetman RAID Recovery. The program will automatically perform a scan of all connected disks, read the ZFS metadata, and recreate the logical structure of the Stripe array based on it. In the main window, you will see the physical disks and the already assembled array ready for operation. Next, select the Stripe array in the list of detected arrays and launch the full scan mode. A full scan is necessary because after files are deleted in ZFS, only a deep analysis allows the program to collect data fragments and restore the correct folder structure. Additional settings are usually not required. Just click Next and wait for the process to complete. After the scan is finished, the full structure of the reconstructed array with all folders and files will be displayed in the working window. If necessary, you can use the Preview feature to check the contents of documents, images, or other files. Select the required files and folders and click Recovery. Specify the save location for the recovered data on a separate medium with sufficient free space and confirm the process by clicking Recovery again. When copying is complete, click Finish. As a result, all files will be recovered and available for work in their usual form. This process guarantees data security, allows you to return files even after accidental deletion, and preserves the ZFS file system structure without the risk of damaging other data on the disks. If this material was useful, subscribe to the Hetman Software channel to receive new instructions, practical tips, and analyses of real cases related to TrueNAS Scale, OpenZFS, and data recovery after failures or deletion. If you have any questions regarding the steps performed, working with Hetman RAID Recovery, or the specifics of using TrueNAS, please leave them in the comments. We will provide detailed explanations and help you find the optimal solution for your situation. Thank you for watching. We wish you stable system operation and reliable preservation of your data.